Welcome to this video on fiber optics technology. The improvement in technology in the current age has made it possible the transmission of light information over long distances, and this is possible by using the fiber optic cable. The fiber optic cable is a thin strand of pure glass to that of a human hair. Long distance transmission of light data could be sent through fiber optic cables. This is Narendra Singh Kapani, father of fiber optics. He was an Indian-American scientist. He was the man who first showed that light could bend. This is Sir Charles Kevin Coe, who won the Nobel Prize in Physics in the year 2009 for his groundbreaking achievements on transmission of light in fibers for optical communication. He is called as the father of fiber optics. Now the question is, why fiber optic cable over copper cable? The reasons are greater bandwidth, speed and distance, security, immunity and reliability, design, field termination and cost. The first reason, the greater bandwidth. Fiber optic cable provides more bandwidth than copper and has standardized performance up to 10 gigabits per second and beyond. More bandwidth means fiber can carry more information with greater fidelity. The second reason is speed and distance. Because the fiber optic cable is made up of light, very little signal loss occurs during transmission and data can move at higher speeds and greater distances. The third reason is security. The data is safe with the fiber cable. It doesn't radiate signals and is extremely difficult to tap. If the cable is tapped, it's very easy to monitor because the cable light leaks, causing the entire system to fail. The fourth one being immunity and reliability. Fiber provides extremely reliable data transmission. It's completely immune to many environmental factors that affect copper cable. The core is made of glass, which is an insulator, so no electric current can flow through it. It's immune to electromagnetic interference, radio frequency interference, crosstalk and impedance problem. You can run fiber cable next to industrial equipment without worry. Fiber is also less susceptible to temperature fluctuations than copper and can be submerged in water. The fifth reason being design. Its small size makes it easy to handle and it takes up much less space in cable ducts. The fiber is easy to test than copper cable. Field termination. Although fiber is still more difficult to terminate than copper, advancement in fiber tools have made terminating and using fiber in the field becomes easier. The last reason being cost. The cost for fiber cable components and hardware has steadily decreased. Overall, fiber cable is more expensive than copper cable in the short run, but it may be less expensive in the long run. Fiber typically costs less to maintain, has less downtime, require less networking hardware. In addition, advances in field termination technology has reduced the cost of the fiber installation. This is the construction of the fiber optic cable. The first one being the core, which is a pure silica glass. The next region is the cladding or the outer optical material which is surrounding the core. The third coating being the buffer coating, which is plastic coating that protects the fiber. And the last one is the jacket, which covers the whole cable. The fiber optic technology works on the principle of total internal reflection. You can see that light, when travels from air to glass with a greater angle called the critical angle, the light gets reflected. The conditions for total internal reflection. The core should have a greater refractive index than the cladding material. The second condition is the light should be incident at an angle of theta of which will be greater than the critical angle theta c. The total internal reflection, you can see more than 2 rays can also undergo total internal reflection in a fiber optic cable. Now let us see the refraction of light. When light travels from one medium to another, it is bent or refracted. This is because light travels at different speeds in different media. The laws of refraction are rays of light traveling from air to glass are refracted towards the normal. Rays of light traveling from glass to air are refracted away from the normal. We can conclude that light bends towards the normal in the optically denser material. You can see that when a light ray is incident from air and falls onto the glass material, this is the angle of incidence between the normal and the incident ray, that is I. The light bends towards the normal, and you can see the angle which is formed between the normal and the refracted ray is the angle of refraction. The laws of refraction states that the incident ray, the refracted ray and the normal are in the same plane. The sine of the angle of incident to the sine of the angle of refraction is a constant. This is called as Snell's law. So, sine I by sine R is equal to a constant. The laws of refraction, when you draw a graph between sine I and sine R, you can see that it is a linear exploration graph. Comparing Snell's law with refractive index, the ratio of sine I to sine R for light rays passing from air medium is called as refractive index of the medium. That is, Nm is equal to sine I by sine R, which is equal to sine theta A by sine theta m, where theta A is the angle of incidence in air and theta m is the angle of refraction in the medium. So, this is the refractive index for various materials like vacuum, air, water, glass, etc. Now, let us see the refraction through a block. This is a glass block A, B, C and D. When the incident ray strikes onto the glass block, an angle A is formed, it bends and then again it gets refracted towards outside and you can see an angle D is formed. You can see that the incident ray and then the emergent ray there will be a lateral displacement. Now let us see what is total internal reflection and critical angle. The inside of a glass block can act like a plane mirror. We can learn more about the total internal reflection and critical angle in the following experiment. This is a semicircular block and you can see a light ray is passed on to this glass block. When the angle of incident is small, you can see that the ray gets refracted outside. The strong ray gets refracted outside and a very little weak ray will get reflected inside. Now, when the angle of incident is equal to the critical angle, you can see the light ray gets incident onto the normal and the angle of incident is equal to the critical angle. So, the light ray will not get reflected or refracted but goes along the side of the mirror. Now, when the angle of incidence is greater than the critical angle, you can see that the light ray gets beautifully reflected within the glass plate. This is called as the total internal reflection. So you can see that this is a fiber optic cable. A total internal reflection is taking place. This is a single strand of the fiber optic cable and this is a bundle of fibers. You can see here that the total internal reflection takes place like this and there is a bend. So the light ray gets bent at the core cladding interface. Not all rays undergo total internal reflection. Only those rays which are within this acceptance cone are capable of total internal reflection. So, you can see this is the core cladding material having a refractive index N1, a core, and the cladding material having the refractive index N2, and a cone is formed. So, only the rays which are within this acceptance cone undergo total internal reflection. So, theta C is equal to sine inverse of root of N1 square minus N2 square. Now, let us see the optical fiber architecture. The input signal is sent to the coder or to the converter. That is being sent to the light source. From the light source, it is being sent to the source to fiber interface. Information, that is the data signal or the light signal, goes from here to the fiber optic cable to fiber to light interface. Light detector is over here which receives the information and that information is sent to the amplifier, shaper or decoder. Here, the information is amplified or shaped accordingly and sent as output. Now, let us see the types of fiber. The fiber are made like this. The core as well as the cladding material is made up of plastic. The second type is the core is made up of glass and the cladding is made up of plastic material. So, this is called as PCS or the plastic clad silicon. The third type is the core as well as the cladding both is made up of glass material. It is called as SCS or the silica clad silica. And now under research we are having non-silicate, that is zinc chloride, that is 1000 times as if it has efficiency greater than that of glass. In plastic fibers, you can see it is used for short distances, higher attenuation, it is easy to install, can withstand stress easily, it is less expensive, and the weight is about 60% less. The fibers are further classified on the modes of operation and refractive index. Modes of operation is the single mode and the multi-mode, and based on refractive index, step index and graded index. The single mode fiber, you can see that only a single ray is passed through the fiber till the end. And in the multi-mode fiber, you can see many rays, one in violet, one in green, one in blue. All of them undergo total internal reflection. So, many rays can be sent in a single cable, that is, many frequency information can be sent to a single cable. The step index fiber, the refractive index of the core is constant. The refractive index of the cladding material is also constant. The light rays propagate through it in the form of meridional rays which cross the fiber axis during every reflection at the core cladding boundary. And in the graded index fiber, you can see that it is a non-uniform refractive index that gradually decreases from the center to the core cladding interface. The cladding has a uniform refractive index. The rays propagate through it in the form of skew rays or helical rays. They do not cross the fiber axis at any time. So you can see this is a beautiful picture of a single mode step index fiber. So you can see that it is in the form of a step. The refractive index of the core is constant. The refractive index of the cladding is also constant. So it is in the form of a step. So single mode step index fiber. Next is the multi-mode step index fiber. Here also the refractive index is constant for the core. The refractive index is constant for the cladding material. So you can see it is in the form of a step. So it is a step index fiber. But many rays can be sent to it. Many modes can be sent through it. So these are the rays which undergo total internal reflection at the core cladding interface. And the third one is the multi-mode graded index fiber. Here you can see the refractive index gradually decreases from the center of the core to the cladding material, and it is variable. So the refractive index is variable, but the refractive index of the cladding material is constant. Here the rays are in the form of meridional rays, that is, they only bend, but actual total internal reflection does not take place over here, and more than one ray can be sent through this multi-mode graded index fiber. Sometimes the fiber are called by numbers like 9 by 125, 50 by 125, 62.5 by 125, which means the size of the core, which is measured in the term of micron, that is 1/1,000,000th of a meter. 9 by 125 means the diameter of the core is 9 micron. 50 by 125 means 50 micron is the diameter of the core, and 62.5 micron means is the diameter of the core is 62.5. Now let us see the advantages and disadvantages of the single mode step index fiber. The advantages are minimum dispersion. All the rays take same path, same time to travel down the cable. A pulse can be produced at the receiver, very accurate, and less attenuation. It can run over longer distances without repeaters, and larger bandwidth, and higher information can be sent at a easier rate. And the disadvantages are it is difficult to couple the light in and out of the tiny core because the core size will be small, and it is highly directive light source is required like the laser light source, and the interfacing modules are expensive. In the multi-mode you can see the advantages are it is inexpensive, it is easy to couple light into fiber, and it results in high signal distortion. Whereas the multi-mode graded index fiber falls in the category between the single mode step index and the multi-mode step index fiber. Now let us see some of the losses in the fiber optic cables. The predominant losses are the absorption loss. The absorption loss is caused due to impurities in the fiber material. Next is the material or rayleigh scattering loss due to the microscopic irregularities in the fiber. Then is the chromatic or the wavelength dispersion loss because of the use of non-monochromatic source. And then the radiation loss which is caused by bends and leaks in the fiber. The pulse spreading or modal dispersion is due to the rays taking different paths down the fiber, and the coupling losses are caused by misalignment and imperfect surface finishes. This is the scattering loss. You can see the scattering loss is due to the irregularity of the material. So when the beam of light interacts with the material, part of it will be transmitted, part of it will be reflected, and part of it will be scattered. The scattered light passes through the cladding and it is lost. Over 99% of the scattered radiation has the same frequency as the incident beam. This type of loss is called as the Rayleigh scattering loss. When a small portion of the scattering radiation has frequencies different from that of the incident beam, this is called as the Raman scattering loss. Next we will see about the dispersion. So dispersion is referred to as widening the pulse as the light wave travels through the fiber optics. A major reason for dispersion is having multi-mode modal dispersion. Different rays arrive at different times. So the slowest rate will come slowly and later. So because of this, there will be some loss of information at the end. So all the information will not reach the destination at the same time. See, you can see the dispersion loss in the step index fiber. So this is a step index fiber and the input signal is like this, and the input, because of the dispersion, you can see the output is like this, whereas it has to be like this and the input is now not as required. In a graded index fiber also you can see this is the input, whereas the output is like this. So this is because of the dispersion loss. Now let us see about the absorption losses in fiber optic cable. The fiber optic material absorbs certain particles, for example OH ions, that is water, during manufacturing process itself. You can see that there is a peak at about 0.95 and at about 1.25 and 1.4. So these peaks are because of absorption of OH ions. So the OH ions will be present in the fiber optic cable, and because of this absorption, there will be some breakup in the information. And next you can see that at about 0.8 micrometer, we will see a Rayleigh scattering loss or the ultraviolet absorption loss. And at about 1.45, the infrared rays are sometimes being absorbed by the fiber optic cable, and this is called as the infrared absorption loss. The fiber alignment imparities. So when we connect a fiber optic cable through repeaters for long distances, sometimes because of the alignment impairments, there will be some losses. So the first one is the axial displacement loss. So axial displacement loss, you can see that this is fiber 1 and this is fiber 2. So these two fibers are not attached in correct axis or in the proper axis. So there is a displacement or misalignment. So the rays will not undergo total internal reflection properly. The second displacement is gap displacement. So you can see that there is a small gap formed between the first cable and the second cable. They are not joined properly. There is a gap being formed. So because of this, the information will not travel completely from this cable to the second cable. So there will be some losses, which is called as gap displacement loss. The third one is called as the angular displacement loss, where the angle of joining between the first cable and the second cable is not correct. The first one is the axial displacement, where the axis is not correct. The third one is angular displacement, where the angle of joining between the two cables is not proper. So if this happens, you can see that the information again will not reach the destination properly. And the last fiber alignment impairment problem is imperfect surface finish. So sometimes you can see that the surfaces which has to be joined is not finished properly and it is not properly completed. So there will be some loss because of imperfect surface finish. Now let us see about the wavelength division multiplexing, which allows multiple signals to be transmitted. You can see there are various signals: the red signal, yellow signal, green signal and violet signal. So all these sources of signal are sent to the fiber optic cable through a single fiber optic cable, and you might be wondering that all these rays will get mixed up. So you need not worry, the deep multiplexer will split the rays. See, you have got back the red ray, yellow ray, the green signal and the violet signal. So you can see that in a single fiber optic cable, about 4 to 32 channels of information can be sent at a time. Now going on to the areas of application, the fiber optic cables can be used in various applications like telecommunication, local area networks, cable TV, CCTV, optical fiber sensors, mining, medicine and military. So you can see this is the central office of the fiber optic cable, and you want to send to various destinations. So the multi-fiber cable is being sent. There is an optical splitter. This splitter will split the fiber optic cables to various destinations like a home, apartment or any business area. This is also another picture showing that the signals is being sent to various multiple destinations. Fiber optic sensors. So fiber optic sensors are used nowadays for ordinary sensors. There are two types of fiber optic sensors. One is extrinsic fiber optic sensor, which has got a light source, a light modulator and a light detector. So this light modulator will sense even the smallest amount of disturbance like the temperature, pressure or strain. Whereas intrinsic fiber optic sensor, you are having a light source and the optical fiber itself will act as a transducer. So here the light modulator acts as a transducer. Here the fiber itself acts as a transducer and does the sensation work over here, and the light is being detected by the light detector. This is a picture of where the fiber optic cable is used in mining. So this is a heavy vehicle. The fiber optic cable is sent underneath to the ground, and the materials, the soil, humidity and all the particles, everything is being absorbed by the fiber optic cable, and this fiber optic cable is being interfaced with the computer. So all the information about the soil, about the material, about the mine is being got into the computer directly from the place itself. Very important and breakthrough the fiber optic technology is the fiber optic cables can be used underwater for long distances, and this is one of the biggest advantage of using the fiber optic cable. Fiber optic cable in medicine. So you can see that this is a person, he is having an infection in his tissues. So he is being laid down, a fiber optic cable is attached and sent through his vocal cord, and this fiber optic cable is attached to a computer, and you can see the computer, this is a fiber optic cable which has been sent into that human body, and you can see that the computer diagnoses and it says what is the type of infection which is being there in that body. Endoscopy with fiber optics. So you can see a doctor is doing endoscopy to a patient who is having some problem in his bowel movements. He is able to see directly through the fiber optic cable what kind of problem the patient is having. The advantages of fiber optic cables are capacity. Much wider bandwidth for about 10 gigahertz can be sent. There is no cross talk in fiber optic cable, and it is immune to many interferences like lightning, electric signals and fluorescent lights, etc. And it is also immune to weather conditions and temperature conditions. And it is very safe to use because it is made up of glass or plastic. There is no, it is a non-metallic material, so there can be no explosion or any shock which can occur over here. It is a long-lasting material. Security, so the tapping is very difficult. You cannot tap any information by using the fiber optic cable. And economy, that means few repeating stations is enough when we use fiber optic cable. Though there are many advantages, there are also some disadvantages, like the higher initial cost of installation is very high, and the interfacing cost is also high, and it is more expensive to repair. That is, you need specialized and sophisticated instrument if you have to do some maintenance of the fiber optic cable. The advancement in technology in the 20th and 21st century is really enormous. So man has to see the positive aspects as well as the negative aspect and use the technology in the right direction. Thank you.